My name is Sharin Vijayan. My card matrix number is CN190254. My group members are Lorani Sulokong, Farzana Balkis binti Muhammad Zulkifli, Nurul Ain binti Muhammad, and Chia Chun Fong. We are going to present about the practice 5. The title is Air Compressor.
Hello, my name is Lorani and I'm going to present about the introduction, objective and theory in Lab 5. Introduction. A pneumatic device that transfers power through an electric motor, diesel or gasoline engine, etc. into potential energy stored in pressure air is known as an air compressor. When the tank pressure reaches its design maximum, the air compressor shuts down. When the tank pressure hits its minimum, the air compressor restarts and repressurizes the tank. To run a pneumatic instrument, it needs a supply of compressed air. The compress can be produced by the use of air compressor. Main type of air compressor can be classified into two, such as positive displacement compressor and dynamic compressor. Next is objective. There are three objectives in this Lab 5, which is the first one is to record and collect data from all electrical motor power, and the second one is to find out the electrical energy cost of compressor using tariff B from TNB company, and the last one is to study and calculate the compressor efficiency of total energy input. This is the theory. There are two types of compressor, which is positive displacement compressor and dynamic compressor. The positive displacement compressor, there is two more, which is reciprocating compressor and rotary compressor. And as for the dynamic compressor, there is centrifugal compressor and axial compressor. Below the equipment of the compressor itself.
Okay, the procedure before we start to run the air compressor. First, the startup. So, in startup, the first is make sure the hair dryer valve is open on the main switch for the hair dryer. Then second is turn on the hair dryer at least for 5 minutes, and then remove the moisture from the hair tank. And then the fourth one is check the oil level at the side glass and check the water level as well, and then check the line is all the way up in the water level. When we operating the air compressor, we need to check the cooling turbo pumps intake and outflow valve are open, so ensure that each valve is fully open. Then turn on the compressor main switch, turn on the start button for the compressor, and then pressure and temperature reading of the compressor. The third is we must always keep an eye out for the inconsistent compressor performance, like excessive vibration and overheated bearings, motors, and packing. The fourth one is we need to keep the lubricating oil levels in the right range. Then we must check the operation of any automated drainers that are provided. The sixth is we have to maintain the regular checks on compressor air, lubricating oil, temperature, and pressures. We also make sure all the readings do not exceed and at the allowable levels for the plant. And then last, the output can be supplied on the plant for sure. We shut down. We have to control the panel, shut off the air compressor. Then we need to drain the air tank afterwards. After that, we have to press the red button at the main switch to turn the hair dryer off, and then we also turn off the power source And finally, we have to remove all hazards, ensure the work environment is clean before leaving.
Hi, I am Farzana Balkis, metric number CN190119. So now I'm going to present the observation section. So from the practical conducted, the air compressor play a vital role in contributing the power efficiency to the plant. Thus, the calculation should be made to determine the cost operated by the power compressor in 8-hour daytimes. Hence, to come up with the formulation, the things that should be done is to record all the electrical power motor at compressor. Next, by the understanding of tariff produced by TMB, student will calculate the total power produced by the compressor. The tariff that should be selected must be compatible with the work done. For instance, in this compressor practical, the tariff that is suitable to use is tariff B, which is low voltage commercial tariff. After that, by using the amount of power consumption 8-hour daytime, calculation for the tariff can be made according to the data collected.
Next, we go to the result. And first thing first, we must know the power, and then we must calculate the usage for 8 hours. So from the data, we must get the Q, the CP value, and temperature 2 and temperature 1. From the data, we get the temperature 1 is equal to 27 degrees Celsius, and convert it to the Kelvin, which is equal to 300.15 Kelvin. And for the T2, that is 80 degrees Celsius and is equal to 353.15 Kelvin. Then we get the data for the Q, which is equal to 2.53 meter cube per minute, and then we convert it to the meter cube per second, that is equal to 0.042 meter cube per second. And we know 1 meter cube is equal to 1,292.2 gram of air. Then we get the 0.042 meter cube per second is equal to 1.87 mole per second. And the CP value we calculate using the formula of 7/2 multiplied by R. R is equal to 8.134, and resulting to the CP value equal to 29,099 joule per mole Kelvin. Then when we have all the data, we can get the value of PR, which is equal to 2.884 kilowatt, and we multiply by 8 hour and resulting to 23.072 kilowatt hour. The next part, we must calculate the usage cost, and for the usage for 1 month, we must multiply the usage consumption from the previous slide, multiply by 30 days, and resulting to 692.16 kilowatt hour per month. And then we use the tariff B, and we get the total cost for the cooling tower is 200. For the air compressor is 287.51 ringgit. And the air compressor efficiency is equal to power output over power input multiplied by 100%, and we get the air compressor efficiency is only 13%.
The biodiesel pilot plant air compressor calculate revealed that the power consumption in 8 hours and the costing for that hours per day at UTHM pilot plant, and to be more specific at the compressor. Besides for the costing, we use the tariff B as a median of voltage for general commercial tariff. So first and foremost, there are many equipment that attach to air compressor, especially when there is a potential energy needed to transfer fluid, raising the pressure. In order to determine its costing, we have to determine the T1 and T2, which are the temperature before entering and leaving. So for the result of both, it shows that the T1 is equal to 300.15 Kelvin, and also the T2 is equal to 353.15 Kelvin, and is found that the free air delivery FLD is equal to 0.042 meter cube per second for each meter cube. And hence for 1292 grams of A is equal to the Q, 1.87 mole per second. And for the Cp, which is the specific heat, is found at 29,099 kilojoule per mole Kelvin. And with this information, we are able to find out the power from the air compressor, ELGI. And it's found that the power consumption was 2.884 kilowatt per day and 692.16 kilowatt hour per month. So according to the tariff B, the compressor will cost 287.51 ringgit per month. And by comparing the power output and the input, we are able to obtain the efficiency of the compressor, which are 13%. And the energy loss may be due to the heat dissipated as the energy loss to the surrounding.
Next, for the conclusion section. So in conclusion, students are able to observe the type of compressor used in the UTHM biodiesel pilot plant owing to this practical. Thus, students are able to evaluate the cost of electrical energy to run a biodiesel pilot plant for 8 hours during the day. So the outcome demonstrates that by gathering data on electrical motor power, which yields 2.884 kilowatt, the power output of the compressor can be reached. In addition, students can demonstrate how to determine the cost of energy using tariffs. In the pilot plant, a compressor uses Rm 287.51 ringgit in energy consumption. Finally, the experiments yielded a 30% air compressor efficiency.
So these are the reference for this lab.